All right, let's dive right into the ISTQB's Certified Tester AI Testing Syllabus. If you're getting ready for that CT AI certification, you already know how dense this material can be. But don't worry, you are in exactly the right place. We're gonna break it all down step by step. So here's how we're gonna tackle this. We've laid out 6 key areas. We'll kick things off with the fundamentals, the why behind it all. Then we'll get into the nitty-gritty, the machine learning workflow and how to actually evaluate models. After that, we'll face the real-world challenges head-on and look at the techniques to solve them. And we'll wrap up with a really cool topic, how AI itself is changing how we test. So let's get started. First things first, the fundamentals. See, before we can even think about testing an AI system, we have to really understand why it's a completely different animal. This isn't just a small step up from traditional software testing. No, this is a major paradigm shift, and you can bet the exam is going to check if you've grasped that core difference. Okay, this slide right here. This is probably the single most important idea you need to burn into your brain. On the left, you've got your traditional software. It's deterministic. You put X in, you get Y out every single time. It follows rules. But on the right, that's AI. It's probabilistic. It learns from data. It isn't explicitly told what to do. Now, for us as testers, this changes everything. Our mindset has to switch from asking, did it give me the one perfect answer, to asking, is its answer good enough? Is it within an acceptable range? That one little change underpins everything else we're about to talk about. So because AI learns from data, the quality of that data is absolutely everything. And the syllabus really emphasizes this, starting with bias. As a tester, you are now on the front line of spotting systemic prejudice built right into the system. See, a biased result isn't just a simple bug, it's a massive risk that usually points straight back to bad or unrepresentative training data. And bias is just one piece of a much bigger puzzle, ethics. The syllabus makes it crystal clear that our job as testers is expanding. It's not enough anymore to just ask, hey, does this thing work? Now we have to ask, should it work this way? Is it fair? Could it actually hurt someone? And these aren't just philosophical questions for a coffee break. For the CTIA exam, these are real, testable quality criteria. So, how in the world do we even start to test for something as complex as bias or ethics? Well, that leads us right to explainability. Think about it. If a model is just a black box, we can see what comes out, but we have no clue why it made that decision. For a tester, being able to peek inside that box, to understand the logic, is absolutely crucial. It's not just for finding bugs, it's about proving to everyone that the system is making decisions for the right reasons. All right, let's keep building on that. We're moving into our next section, which is all about the machine learning workflow. This is really the engine room of most of the AI systems you're gonna see out there. Now, you're gonna wanna know this workflow backward and forward for the exam. But here's the key insight for us as testers. Quality isn't just something we check at the end anymore. Nope, it starts right at step 1. We should be in that room during problem definition, asking questions like, is AI even the right tool for this? What are the ethical risks? We can add a ton of value long before anyone's written a single line of code. At the very heart of that workflow is the data. And you absolutely have to understand the difference here. The best way to think about it is this. The training data is like the stack of textbooks the AI gets to study. The test data, that's the final exam, with questions it has never ever seen before. If you let it see the exam questions while it's studying, that's cheating, right? And in AI, it gives you a totally false and dangerous sense of how good your model actually is. And that leads us straight into 2 classic problems you'll run into: overfitting and underfitting. Overfitting is like a student who just memorizes every single answer in the textbook, but doesn't actually understand the concepts. They'll fail the real exam. Underfitting is like the student who barely studied at all. As a tester, you need to be able to spot the signs of both of these to make sure your model is genuinely smart, not just a good memorizer. Okay, so we've trained our model. We've tried to avoid traps like overfitting. But how do we actually prove that it's any good? That brings us to our third section, measuring model performance with cold, hard numbers. This little grid is called the confusion matrix, and trust me, for the exam, this is one of your most important tools. It's what ISTQB calls a K3 apply objective. That's just a fancy way of saying you won't just have to define what it is, you'll actually have to use it to solve problems. For any model that classifies things, like spam versus not spam, this matrix tells you exactly where it's winning and where it's failing. And from that matrix, we get all these different performance metrics. But, and this is a big but, the syllabus hammers home that no single number tells the whole story. For example, if you're testing an AI for medical diagnosis, you probably care most about recall. You want to catch every single possible case of the disease, even if you get some false alarms. But for a spam filter, you might care more about precision. You really don't want to accidentally delete an important email. It's all about the context. So, we get the fundamentals, we know how to evaluate a model. Now, let's talk about what makes this job so hard in the real world. Let's dig into the specific challenges we face when testing these incredibly complex systems. You can pretty much think of this slide as the job description for a modern AI tester. Seriously, you need to be ready to talk about every single one of these points. Like, how do you test something when you don't have one single correct answer to check against? That's the test oracle problem. How do you test for bias? How do you protect against brand new kinds of attacks? Your test strategy, both for the exam and for your job, needs to have an answer for all of these. Let's just double-click on one of these for a second. Non-determinism. This is a huge one. What happens if you run the exact same test twice and you get two slightly different answers, but both answers are still pretty good? Did the test pass or did it fail? See, this is what forces us to move away from simple pass/fail thinking and into the world of statistical validation and acceptance ranges. It's a whole new way of working. Okay, so we know the challenges. The big question now is, what do we actually do about them? Section 5 gets into the practical side of things, the specific techniques and specialized environments we need to get the job done. To tackle these new challenges, we need a mix of old and new tricks. Metamorphic testing, for instance, is a brilliant way to handle that oracle problem. Instead of checking for one specific result, you check for relationships. For example, if you ask an AI for hotels in London, and then you ask for cheap hotels in London, you'd expect the second list of results to be a smaller part of the first list, right? That relationship should always be true. The exam's going to throw scenarios at you and expect you at a K4 analyze level to pick the right tool for that specific job. And it's not just our techniques that have to change. Our entire test setup needs an upgrade. You're going to need specialized hardware, like GPUs, just to handle the raw computing power. You'll need huge amounts of storage for all that data. And super importantly, for things like self-driving cars, you need safe virtual worlds where you can run millions of tests without anything bad happening in the real world. The syllabus expects you to know exactly what these environments require. And for our last big topic, the syllabus brings this whole thing full circle. We've spent all this time talking about the challenges of testing AI, but what about using AI for testing? This is a really exciting part. AI isn't just the thing we're testing anymore. It's becoming a powerful tool that we can use ourselves. I mean, what if an AI could look at your code and predict exactly where the bugs are most likely to be hiding? Or what if it could dream up thousands of creative test cases that you would never even think of? The syllabus covers how AI can supercharge our own skills, making us way more efficient and effective testers. And that's our whirlwind tour of the core syllabus content. We've hit the main themes and the key things you need to know. So let's wrap this up by looking at the practical details for your exam day. Okay, let's get down to brass tacks. Here are the numbers you need to know, straight from the source. It's 40 multiple choice questions, and you've got 60 minutes. That works out to about a minute and a half per question, so you've got to be on your toes. The magic number to pass is 65%. And don't forget, this isn't a standalone certificate. You have to have your foundation level first, because all those core testing principles still apply here. So we'll leave you with this final thought. Getting this certification, it's not just about passing another test. It's about getting the skills you need to answer the really big questions about the next generation of software, to make sure it's not just working, but that it's also safe, that it's fair, and that it's trustworthy. Good luck with your studies. You've got this.